So the only other thing that we could do is now we could say, okay, that's great, we like that, but let's try a different version where the rotation of the outer circle might have a multiplier. Instead of it simply being tied to the circumference of this related to a partial circumference of the inner one, let's let the outer circle spin at a faster rate. And this will be more like the kind of spirograph. Let's let me just make a second version. And this is easy enough to do. Let's copy the whole definition. Control C, Control V. We'll slide it down. And remember, all we have to do now is give it an extra point. Doesn't matter where. And let's set this point. So this will then allow us to reconfigure or relocate a whole other copy. So we can have one copy that's above. We can group this, select all of it, middle mouse, and then group. And then we can group this one. What I want to change is just the multiplier of how the first circle moves around the second circle. Let's say that that's independent. It's no longer tied to that. So we don't need any of our expression within here, except maybe a multiplier. So let me do that. We know that this is coming over to here. Here's a little trick. Let's just double click on here. So that adds a little relay switch. We can delete this, but it allows us to kind of pick up from here in a second. So I'm going to delete, let's see, let's keep our A times B. I'm going to delete this and delete this. And what I want to set for A is a multiplier. And so this will just be a slider. And let's say it's going to go anywhere from 1, which will be 1 rotation, to 10. And so now, as whatever is coming in from our slider, that's going to be a 1-to-1 relationship to this. Let's see if this is working. And it is. So that multiplier of 1 means that the outer rotation is 1 full rotation as the other one goes around. But watch what happens if we change that. Let's see. Can we delete this? We can. So let's change that to 5. So right now, so far, we've only affected the animated part. We can see that that circle is going to rotate 5 times as it makes 1 orbit around the around the inner circle. So that's good. Now let's just change our numbers down below, and that we can use the multiplication, and let's use that same multiplier and tie that in. And just because I like having all of my sliders back here, we can pull it back, and let's rename it. Let's call this frequency multiplier. And so as we change the rotation, we can see the way that that now swings around these. We can hide our point in Rhino. And what we could even do is we could tie together our animated rotation so that as we move it for one, we move it for both. You just have to kind of add those back in, and that would be fine. But here's where we get to the spirograph with changing your outer circle, changing your inner circle. And there's really nothing to stop us from changing this to be an even higher number. So we can increase our multiplier. And again, this is starting to get, the interpolate curve starts to get a little janky, because we should probably give it more steps, right? If we turn the points back on, what we'll see zoom in, we'll see that the geometry will actually begin to change as we add more points. So now we're at 300. Turn the points back off. And now we start to get that rotation. We can animate it, but it's multiplied so quickly. You'll see that that's spinning really, really fast. So it's going to rotate 27 times fully in the time that it goes around there. We can change our outer circles and the inner circle. So play with this a little bit. But what I really wanted to get you to see is just how we can begin to manipulate a few of these things. We can get pretty different outcomes between them, between the top and the bottom. And that, the class is simulation and prototyping. In some ways, I'm going to keep using those terms interchangeably, right? So that we're simulating some kind of reality, some kind of orbit, but we're also simulating possible geometric outcomes. So in some ways, there's a prototyping aspect of this for us, right? We just simply copied our entire Grasshopper definition and changed one of the inputs that gave us these two varied outputs. And so play with these, start to get a sense for how we're rotating something else that's rotated already, and how that starts to produce these types of different outcomes. So I hope you enjoyed this. I hope you had fun, and let me know if there's any questions related to this. Thanks.